So we're going to take a look at the graphs of some sine and cosine functions. We'll be playing around with the amplitude and the period. Here is our first equation, and we're going to start off by listing what we know. So here we know that the amplitude is equal to 5. So that tells us about our range, that our graph is going to go up to 5 and down to -5. B is the frequency, which is 2, meaning we're going to have 2 cycles every 2 pi. And then the period is 2 pi over b, so that's 2 pi over 2, which is just pi. So the length of each cycle is pi. So let's start by drawing some axes. We're going to show 2 cycles in the positive x direction. And I really just start by saying I've got to graph a sine function, and sine functions all look like this. There's one cycle. There's another cycle. So all that's left to do now is label with the parts that we found before. Now we know the amplitude is 5, meaning that the highest point must be 5, and the lowest point is -5. We know that the frequency is 2, so there should be 2 curves every 2 pi, which means that this graph here, here's one curve, here's another curve, that should be ending at 2 pi. Our last piece of information should really confirm that. We found that the period was pi, meaning that the length of one cycle, here's one cycle right here, this right here ending, that has a length of pi. So doubling that, we get our 2 pi. Now let's label some points in between. We know that in between 0 and pi, we've got pi over 2. In between pi and 2 pi, we've got 3 pi over 2. And let's go even smaller. Halfway between 0 and pi over 2, we would find pi over 4. So we've got to find these over here, where we've got our extrema. And there are a few ways of doing this. You could, let's say, average these two together to find the middle. But what I kind of like to do is just count. We know that we've got 1 pi over 4. This is 2 pi over 4, so this must be 3 pi over 4. Then 4 pi over 4. Next is 5 pi over 4. 6 pi over 4. 7 pi over 4. And last is 8 pi over 4. And then all that's left is to label our graph with the equation. And that's it. Okay, here is the same equation, except this one has a negative sign in front of the amplitude. Now the amplitude is still 5. And the frequency is still 2, and the period is still pi. So our graph is going to look mostly the same. Except as we learned in Chapter 1, if we negate a function, that means we reflect that function over the x-axis. So I'm going to draw the same graph as before. We're going to start here, except it's going to be the reflection. So it would decrease first, increase, there's 1 cycle, decrease, increase, 2 cycles. Label your axes, 5, -5. That was pi, 2 pi, half of pi, 3 pi over 2, a quarter pi, and here we go, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 2 pi is 8 pi over 4. Label with the graph. And that's that. So if your function is negated, it means that you're going to reflect the graph over the x-axis. Okay, here we've got a cosine graph. I'm noticing that it's negative, so that means we're looking at a reflection of cosine. Our amplitude is 3. Our frequency is 1/2. So that means we're going to have half of a cycle every 2 pi. And the period is going to be 2 pi over 1/2, which is 4 pi. So the length of each cycle should be 4 pi. So here we go. Draw our axes. And I'm going to draw 2 cycles of cosine, but reflected. So instead of starting up here, we're going to start down below the x-axis. So here's cosine. Here's 1 cycle. And here's 2 cycles. Okay. Labeling the y-axis, the amplitude is 3, so that goes up to 3 down to -3. Here we found the period. It's 4 pi. So that means that 1 cycle ends at 4 pi. So the second cycle would end at 8 pi. We'll do a little more labeling. Halfway, this would be 2 pi. This would be 6 pi. Right here, we're going to have pi, 3 pi, 5 pi, 7 pi, and then we label with the equation. Okay, this is our last one. The amplitude here is 10. That's an equals. Our frequency is 2 pi, which means that our period, which we know is 2 pi over b, b is 2 pi, we get 1. And we'll talk about what that means after we get a sine graph here. So here's x and y. We're going to draw 2 cycles of sine. Starting at the origin, here's 1 cycle, 2 cycles. All right, amplitude is 10, -10. And now watch what happens here. This says that 1 cycle has a length of 1 unit. So here's 1 cycle. It has a length of 1 unit. So the second cycle would end at 2. Notice that this is not in terms of pi. Let's label the rest. This would be 1/2, 1/4, 3/4, 5/4. This would be 6/4, which is 3/2, and then 7/4. All we need to do now is label the graph. And we're done. Now we may have labeled the x-axis differently than we did in the other problems, but it's the same x-axis. It's just the other ones were in terms of pi. So here's our 1, here's 2. If we extended this out a little bit longer, we'd get to 3, and just a little bit after that we'd have pi. So pi is still appearing on this number line. We're just writing it so that it's not in terms of pi. And here is your summary for graphing sine and cosine functions. You want to find the amplitude and the period, and the frequency will help you find that period. You're going to graph 2 cycles of sine or cosine, depending on what they give you. Remember, if the coefficient is negative, that you want to reflect the graph over the x-axis. You start by labeling your range according to the amplitude that you found, and then you label the x-axis so that each of your cycles has a length equal to the period that you found in the first step. And don't forget to label your axes and your graph.